Hi everyone, Matt here, and I wanted to first of all, let me welcome everybody today. And just to begin the presentation, say, first, we're super excited to see everyone's interest in what we've been up to, and stress that we've been hard at work this last, it's got to be 6 months now, in addition to everything else that we've done with Eagle, executing on a vision that began really even before the acquisition of Eagle, and really which drove the decision to introduce electronics design to Autodesk. And now hopefully it's no great mystery to this audience what we've been up to. If we intended to keep anything a secret, we probably should have come up with a better name for the product than Fusion. But today we're really here to show you a sneak peek at the first phase in what's really an ongoing strategy to bring together electronics design, mechanical design, and manufacturing into a single, highly integrated workflow. And though this is just the first stages, we will be rolling this out as phases. So the users of Eagle or the users of Fusion aren't left waiting for the end state before you get the benefits of a more tightly coupled workflow. That being said, drop out of my slide deck here for a quick second and jump up onto the website here. And this is an interesting project that we've been working on. It's actually for a hands-on workshop that we're going to run at Autodesk University. And it's really intended to get real users building something end to end. So that includes not just the enclosure here, we'll have CNC equipment on site, laser cutters on site to actually build out the enclosure, but then also to design the schematic, build out the printed circuit board, and I'll do a workshop teaching people how to solder surface mount components, kind of take people through the overall process. And it happens to be a speaker for an iPhone with a headphone jack, what have you. But it was a fun little project because really what it did was it was one of the first demonstrations we did internally of a true end-to-end workflow using both Eagle and Fusion 360. And it really forced us to tighten things up quite a bit across the space. Now, before we get here, it's important to kind of highlight the overall workflow and how all of the various pieces fit together. So bear with me, we'll go through a few slides. Later I'll do a live presentation. So with that being said, I'm going to jump back into my slide deck for a quick second here. And I want to talk about kind of when we evaluated this whole product pipeline, what we felt were really table stakes. What were the requirements that we gave ourselves for a workflow between Eagle and Fusion? The first item on the list was that it had to be bidirectional. So we needed to support changes at both ends. That included changes to the board shape, to component positions, adding slots, adding holes. And the changes in the MCAD space had to be intelligent enough to account for the difference in dimensionality. So for example, you didn't want parts that existed in the right XY location, but whose Z-axis was off in the weeds somewhere. So we really needed to refine a lot of processes. And, quite candidly, we wanted to do something which was data-centric and not file-centric. So not focused on passing step files back and forth, or even worse, IDF files back and forth. We wanted something which really had a data structure in between, or a data model in between, that would allow the information to be shared seamlessly between the different ends. And, it also required that we built out a new library system, or at least expanded the library system to account for both the ECAD data and the MCAD data. So we know that in the PCB world, we've got PCB footprints, they're two-dimensional, they exist on an XY plane. But in the MCAD world, we've got three-dimensional structures. And at some point, we have to marry up the sketch plane on which the 3D model was drawn against the ECAD component and actually handle the orientations and relative positions, what we term the insertion matrix. The next item was we really had to support a deliberate push-pull step So anybody can make the decision whether or not they're going to push a change, which should generate a new version of the data. And then likewise on the other end, whether or not I'm going to pull that change. And that also included the ability to add comments and even roll back various versions. And lastly, we need to support a whole variety of different user types. So, it's no great mystery that there are a lot of EAGLE users who own a license of the software and do both the electronics and the mechanics. Likewise, there are a lot of Fusion users who own the software and do both their mechanics and their electronics. But we also had to deal with the scenario in which you had a mechanical engineer and electronics engineer. And even those people distributed across different geographies. That also included the ability to communicate with one another. So beyond just supporting the data across different geos, it meant also the ability to comment on data, produce markup, generate drawings, any other types of outputs, share and socialize content, all that other sort of stuff. So there's quite a lot in the way of requirements that we placed on ourselves as we started to build this out. And I think what you'll find today is that we've hit, at least in some ways, each one of these different requirements. Now, the workflow that I'm showing you today is a preview. The intent is that we'll get the first instance of this out probably over the course of the next several weeks. And after that, we're looking for feedback. And obviously, we'll do continuous improvements on this workflow. So this is the beginning of a process. It's not the end state. Now, let me first start the discussion with managed libraries. And I want to talk briefly about exactly what we mean by a managed library. For those of you that are new to EAGLE 8.2, this may be a foreign concept, but for those of you that have been following the EAGLE version 8 lineage, you'll know that 8.2 introduced the concept of a managed library. And this was a big concept, and one that may feel, at least on the surface, a bit confusing to many of you because it's a little heavy to kind of get your head around. And the managed library concept really started in part as a way for us to manage the content pipeline into the EAGLE desktop client more effectively. So, take as an example the libraries that many of you use that ship with the product. Or the libraries that you download from the community every day. So you go to Dangerous Prototypes and you download Ian Linne's library. You go to Adafruit and you download the Adafruit library. In the past, the libraries in EAGLE were only updated either when we released a new software, or if you happen to have the good fortune to stumble across an update on the Adafruit Git repository, or you got a notification from somebody like SparkFun, and recognize that they introduced a new revision to their parts library, and then you went ahead and downloaded it. So, as we started to think through managed libraries, we got to thinking, right? This was painful, and we knew that we wanted to build this continuous thread between EAGLE and Fusion. So we started to look for ways to handle a combination of things, not the least of which was more frequent updates to content inside the desktop client. And then likewise, how we would create the association between EAGLE content and the Fusion equivalent, or the 2D data and the 3D model. And, quite frankly, it felt like with one carefully aimed stone, we might be able to knock over a few pretty major requirements, not the least of which was this connection between the electrical and mechanical worlds. Now, in fairness, 8.2 managed libraries was just a way for us to test out distributing things like Adafruit's library being sourced from a Git repository, SparkFun, Seed Studio, and delivering that down to the desktop client in a way then in which you could do more frequent updates of the content and recognize when a component in your design was out of step with that library. This is really the beginning of Managed Libraries 2.0. And when we started to look at what we really needed for both Fusion and EAGLE, and the concept of a library sort of existing in between these two spaces, a number of requirements came up. First of all, we wanted to support direct storage. So we could upload the content, it would be stored on the server. But then we also wanted to support things like dynamic links. So links out to something like a Git repository. You could say, hey, this is where I store my libraries in Git, and I want to see that content in Eagle. The advantage of doing this in a more centralized kind of cloud-oriented way was that it made it possible then for the Eagle users to also share their libraries with other people. Decide, what do you want to publish, right? Do you have a library and you think the parts are pretty good, you think it's worthwhile, you think you want to make it available to people? This is a heavily community-oriented product with a really strong open source ethos. And we wanted to try to make the distribution of that much, much easier. However, and you'll see in the last point in this list here, we wanted to do that in the right way. Secondly, we needed a place to store 2D and 3D models for the data and their associated insertion matrix. It kind of felt like a non-starter if the Fusion user, the mechanical engineer, for example, who doesn't know anything about the electronics of the system, had to know how to use Eagle to be able to build a library part and associate a 3D model with it. Likewise, it felt like a bit of a non-starter that the Eagle user had to jump into Fusion and figure out how to do the association there. So we needed something of neutral territory in between those different experiences, and something that felt pretty lightweight. Now, with that, one of the other requirements was the ability to share, publish, subscribe. We have different users for Eagle, some of which produce an enormous amount of content. We have manufacturers and distributors who would love to give you access to their parts in an Eagle format. Likewise, we've got really some amazing authors of content. Adafruit, SparkFun, Seed Studio have done an enormous job driving content out to the community. So we needed some system for sharing, publishing, subscribing, and then versioning all of that content. And lastly, you had to own your own data. Now, we're going to go ahead and just take a look here at managed libraries in a little bit more detail before we get into creating a board shape in Fusion there. Here's an example of managed library sort of 2.0. And this is targeted for the 8.3 release of Eagle. The idea is that I can upload any sort of an Eagle library, and I can do that conveniently through the Eagle client. So I can go into the control panel, for example, in Eagle, select a library and say, hey, I want to go ahead and manage this library online. What that will do is it'll push the content online. Everything will be private by default. But as that content gets loaded up there, then I'll be able to make the association between the mechanical data and the electronics data. The other piece, which is critically important, is it will generate versions of that data. So anytime that something changes, each individual component, anytime that a component changes, a new version of that thing will get created. Now, as far as my desktop is concerned, the library itself will continue to exist on my desktop. And in fact, under libraries, I'll have a list of whatever managed libraries I currently have. So the library content still exists on my machine, still in an XML format, but in the browser and in the web experience, what I'm doing is making the association between the mechanical data and the electronics data, and ultimately being able to load something like a step model and associate a step model with a particular component. So that being said, I want to jump into kind of the package editor here. And here's an example of a component which happens to have a pretty convenient package already selected for it. But let's just imagine that you didn't have anything. All you had was a black box, and all you really cared about was component height. In that case, you should be able to use just a black box, define the black box geometry, and say, hey, I want to build the mechanical equivalent of this part, and the only thing I really care about is component height. Likewise, we wanted to be able to support your ability to upload, for example, a step file. So I can come here, click Upload Step. I'll go into the directory here for Eagle. And inside of my Eagle directory, I'll jump in here and I'll grab a step file for this particular part. As it goes ahead and loads up that step file, once that's done, I can go ahead and use a variety of tools to sort of position that and get the origins right with the step file loaded onto the actual component itself. So, take as an example this. The component is obviously not at the right orientation, but we have some pretty convenient and pretty snappy alignment tools. Now, the part is actually on that plane over there. I can go ahead and say, okay, snap that component to the center of whatever that package is here. You'll see pin 1 and pin 1 here indicated in silkscreen. And really, really fast going ahead then and associating a model with a particular part. Once that's done, I can create a new version of that particular part, and that new version of that part becomes something that then is used in every subsequent design when I synchronize that data from EAGLE over to Fusion, or from Fusion back over into EAGLE. I also have the ability to select from a collection of packages, and it's really important to understand that we've been working behind the scenes with a whole variety of parts manufacturers looking for all of the 3D package data that we could get. So you can expect that with subsequent releases of EAGLE, there will be an enormous library of mechanical content. We focused initially around things like connectors because they tend to be some of the hardest things to model in your mechanical tool. So you'll be able to simply select a package and associate a package with a footprint. Now, obviously, this is all sort of at the library level, where it's kind of the bridge between the electronic space and the mechanical space. But ultimately, what you're really after is building something like this. And so I want to talk about going from EAGLE's desktop client, something like, just the PCB editor over here, and linking that to a board shape in Fusion. Now, before we do that, let me go ahead and talk a bit about the sort of bridge here between these two environments. And you'll notice here, I'm going to go ahead and view this design on the web. This happens to be a PCB, which has an equivalent in Fusion. And I just want to talk about the bridge. What we did is we decided that we needed to create a PCB object, which was representative of both the electronic space and the mechanical space. And that needed to exist and be versioned independently of either one of those two systems. And that push-pull mechanism is what initiates a new version. So you'll see here I've got 23 versions of this particular audio amplifier design. And I want to go ahead and just share with you. This is Fusion Team. This is a component of Fusion out of the box. And what this does is it provides an online viewing experience that allows me to go in and do things like markup, go ahead and take a exploded view of the board if I wanted to, take slices of the board, measure the PCB, go ahead and make comments on things, share things and socialize content, even go ahead and download the content in a whole variety of different formats. So if I decided that I wanted to use Inventor, if I decided that, hey, I wanted to bring this into SketchUp, or I wanted to produce an OBJ or a DWG or DXF, all of those export capabilities exist here. The nice thing about this experience is that I can go ahead and share that content with anybody just by providing them with a link to that particular design. And then I can control also whether or not they need password access to that particular PCB. But this provides a view into the component that we're building in between here. Remember before I said that we didn't want to build something which was purely file-centric. We wanted something which was data-centric. This is a representation of what we call the Fusion PCB. The Fusion PCB includes things like board shape, component positions, holes, slots, that sort of thing. But it also includes reference to the individual components, both their mechanical and electrical equivalents. And all of that stuff is stored and then versioned automatically. So as you link data from both Fusion into EAGLE and EAGLE into Fusion, you'll actually be creating versions each time that you do the push-pull process. So how do we get to something like this? Well, let's go ahead and take one workflow just as an example. I'm going to go ahead and start, first of all, by creating a new design in Fusion. I'm going to create a new sketch, and then I'm going to grab a sketch plane. Now, you'll notice here I've got my XY sketch plane, which happens to be Y to the green, red over here. I'm going to save myself a little bit of headache and kind of get the orientation of that consistent with what we would expect in PCB. I'm going to go ahead then and then draw out my sketch. And I'm going to create a couple of lines here, and I'll just do something simple. Maybe I'll add a little cut in it just to ensure the fact that there's something actually to look at and that it's not just the same old rectangle. But if I go ahead here and I select the board, you'll notice then in Fusion, if you have the right preview feature enabled, that you're going to have a command called create PCB. Now when we release this, we're going to release this in what we call checkbox preview for Fusion. What that means is that within Fusion, you're going to go into the preferences, and under preview, you're going to choose the option here for PCB feature. what that'll do is go ahead and give you then this command to create a PCB from whatever the selected object is. So I'm going to go ahead from my sketch, choose create PCB. That's going to go ahead and switch me over rather into a new workspace. And this new workspace here will have a different set of commands, different from what any Fusion user might be used to, but things which are focused really around generating a PCB board. So I'm going to go ahead and grab my PCB profile here, and when I choose that, you'll see here that this is telling me which way is top. I need to set an origin for this. I'm going to set the lower left corner over here to be my origin. At that point, I can go ahead and click OK, and I end up with a board object. Now from here, I've got a series of other commands. I can go ahead and do some measurements on the board shape. I can modify and move components around. In this case, I'm going to keep this simple. I'm just going to go ahead and choose to produce the PCB. Now I'm going to go ahead and save, and we'll just call this something silly here like Hello World. I'm going to go ahead and click save on this, and now I've got my Hello World PCB over here. Now, let's jump over into EAGLE for a second while that saves. It produces a new version over here. This board is already linked to something, so we're going to go ahead and close this design. And instead, we're going to go ahead and open up another design which doesn't have a link to an existing Fusion PCB. In this case, I'm going to choose a command here, Fusion Sync, and you'll see here that I've got the option to link then to an existing Fusion design. When I go ahead and click Next, I get a list of all of the designs that I've ever created in Fusion and all of the other folders that I might have ever created in Fusion. Under Hello World, I see an example of the PCB. I can go ahead and click OK, at which point then you'll see that the button over here, the Fusion Sync command, becomes red, and now I've got the ability to pull from Fusion. Now the out of sync command here is obviously on the push side as well, but I'm going to go ahead and pull in the new board shape. And the comment that was created when I first created the PCB over in Fusion is automatically copied over here. So if I put something in there like, hey, added a slot to the board, added a couple of holes, etc., etc. Now I'm going to pull the design in from Fusion. It's going to take a few seconds to actually load the design from the Fusion side over there. I'm going to bounce back over to Fusion for a quick second here, and you'll notice that we're currently at version 1 of this PCB object. Now as we make changes, whether it's on the EAGLE side or on the Fusion side, that version will change. So jumping back into EAGLE over here, I go ahead and click close. Now you see that the board shape that we had created has actually been loaded in the system over here. Now, that's all well and good. I'm going to go ahead and maybe propagate a few changes, then back over to Fusion as well. And I want to mention something here, first of all, because it may not be obvious, certainly for the sort of experienced EAGLE user. You're looking at this and saying, hey, this doesn't look like EAGLE necessarily. This is EAGLE 8.3, and you'll notice here that the board shape is now an actual object. It's still lines and arcs on the dimension layer. So, if I go ahead and I grab a circle here and I say I want to go to the dimension layer and I place a circle on the dimension layer, what it's going to do is actually punch a hole through the board. Likewise, if I go ahead and I place a hole, and we'll grab a hole here and we'll change the geometry of the hole to 150 mil diameter, something like that. Drop this here, here, and here, and my holes will become holes through the board itself. So I can make changes over here. Now at this stage, I'm going to go ahead and push the changes that I currently have back over to Fusion. So let me close this for a second. I'm going to save my board, launch this again, and then I'm going to push this over to Fusion. And the first thing that's going to pop up here is a list of components in my design and whether or not those components have 3D packages associated with them. So in this case, I'm going to go ahead and just say pushing components and holes to Fusion. So I'll go ahead and click push, and what that's going to do now is it's going to go ahead and pass the information over into Fusion. Now I've gone ahead and I've pushed this, and if I go over to Fusion here, you'll see now I've got version 1, but if I click on this, version 2 then suddenly shows up in the system over here. So I want to go back then to, say, an existing design. We'll take something like our audio amplifier over here that happens to be loaded over here. I'm going to close our Hello World app or our Hello World board for a second here. Now, what happens if on the Fusion side I decide that I need to make a change? A couple of changes, which may be some pretty obvious ones. I may want to move a connector around. I may want to go ahead and add a slot to a board. All of those are pretty common things, and so I want to show you that workflow. Before we do that, let me go ahead into Eagle, and I want to close this version of the board, and I want to open up the one which is currently synced to that version of that Eagle file, or of that Fusion file. So I'm going to go ahead and open this up. I've got the PCB over here. Things are a bit out of sync right now. That's just because I've been doing this back and forth all day. You'll see here now that I've got the board. The board is in fact the equivalent of what's over here in Fusion. Now, as a preemptory step, simply because we're going to go through this process and I'd rather not have it create a whole bunch of tracks kind of moved to random locations, that sort of thing, I'm going to go ahead and rip up the design and just rip up the signals. Now, obviously, you don't want to have to do that for a significant design. My suggestion is as a preemptive step, rip up the connections, which are going to be connected to those components, be moved as a part of the synchronization back to Fusion. But with the board actually ripped up, I'm going to go ahead and jump back over into Fusion. I'm going to make a couple of changes to this design. First of all, I'm going to edit the design and I'm going to move a part. So I'll go over here, I'll grab my component over here, and I'm just going to make a move on this particular part. So I'll move the connector over to this location. Imagine I say, hey, listen, I need a connector over in this spot. Now, from here, I'm going to go ahead and choose Finish PCB. PCB is updated. I'm going to go ahead and Control S to save, and I'm going to say moved audio jack headphone. So, okay, that change has actually been made. Now we're going to switch from version 23 to version 24, or version 22 to version 23. Not exactly sure. Here we are. Now we're at version 24. Now, I'm going to jump back over into Eagle, and you'll notice here that the Eagle board is out of date. A pull is required to synchronize this. So I'm going to go ahead and choose pull. I'm going to go ahead and pull this then. You'll see here my comment, moved audio jack headphone, and I can pull that over into the Eagle environment. So again, bidirectional synchronization back and forth between these two different environments should be very, very smooth and seamless. Now, a couple of things worth noting. Mechanical software is not the same as electronic software. There's going to be a little bit in the way of teething issues, things that you have to kind of understand about the mechanical world if you're an Eagle user, or the electronics world if you happen to be a Fusion user, because the terminology, the workflows are not entirely consistent. So let me give you another example. Let's jump over into Fusion. I just want to put a slot in this board. Okay, so to do that, in the mechanical world, the solid object is actually linked back to its original sketch. So I'm going to go ahead and edit the sketch, and you'll notice here that I have a slot already sort of conveniently added to this board here, was included in the sketch here. So from there, everything kind of looks okay. Sketch is all good. I'm going to go ahead and stop sketching. Now I'm going to go back to the PCB, and I'm going to choose here to edit the actual PCB itself. So the sketch has changed. Now the solid hasn't actually changed yet, but I'm going to go ahead and edit the PCB. Now from this, it's going to prompt me, select your PCB profile. I'm going to select this PCB profile here. And what I'm going to pick here is going to be this shape here. My origin, I'm going to go ahead and set the origin over here. Click OK, and I end up with a PCB with a slot in it. Okay. Now I'm going to go ahead, I'm going to hit Command S, save this. We'll say added slot to PCB. Go ahead and click OK. All's right with the world. Now I'm going to go from version 24 to version 25, or version 25 to version 26. I've hit save a couple of times here. So let me go ahead, jump back into Eagle again. Eagle indicating the fact that Fusion is out of sync. I'm going to go ahead and grab this and pull in my slot. Added slot to PCB, so my comment came through. Then I'm going to go ahead and click pull, and that's going to pull this into the EAGLE environment. And now with the change in board shape, you should see that we've got some very, very clear indications of the fact that there is now a slot in the board. The good thing is that all of that stuff, all that hard work that we did with walk around routing and those sorts of things, they observe slots in the board now. So they'll actually follow the slot in the board, ensure the fact that you don't have an area where you've got a track running through a section of board area in which the board shape has been cut away, or the board has actually been cut away. Now, I want to stress just kind of one final point on all of this as a part of this demo. And I'm going to go back to kind of an earlier revision of this board just to kind of make a point here. I'll kind of wind back. Version 16, I think, was the one that we were looking at on the website. I'm going to promote that to the current version of the board. That'll create my version 27 of this. So I'm going to close 26. Double click, open up 27. And I want to stress a couple of things here. First of all, this is not electronics design and 3D visualization. This is electronics design and complete mechanical design. And with a library system that helps to bridge the gap in between those two different environments. The other piece which I really want to emphasize there is that this isn't just about board shape and component positions, because once you have a full mechanical design tool like you have with something like Fusion, you have the ability to do things like simulate something in the design. So I could go ahead and run a simulation, assign some thermal properties to some components, and run a thermal simulation of the board to find out how that's actually going to behave inside of the enclosure. Likewise, I can apply a material property to the board itself. And in applying a material property, I can look at things like stress and do stress analysis on the PCB. So there's a whole variety of different analyses that are available to me. Likewise, because it is a mechanical design tool, I have the ability to do things like CAM. So could I mill out the tracks on my board? I also have the ability to do things like produce drawings from it. I have the ability, likewise, to do something like 3D print this along with the enclosure. So there's a whole variety of things which become available to us in that space. And likewise, Fusion comes with a whole bunch of additional technology which is available to us. The ability, again, through Fusion Team, and again, this comes as a part of the Fusion license, to do things like mark something up, to make comments about something. I can come in here and have a conversation about a design between me and the mechanical engineer. I can view drawings, produce drawings. I can see where something has actually been used. So this PCB object, I can see how many designs have we actually used that in. Hope you enjoyed the presentation today. If you have any questions, again, forums.autodesk.com. Reach out to us. The support community is, of course, available to you as well. And I'll be up on the forums. You can jump onto the Fusion forum or the EAGLE forum and ask questions. Thank you.